Pod React.
This is secret where the cable silent have and system is no nano. Wow, rockets are amazing. Oh, hi there. Up until this very point, everything React knows has been trapped inside the Arduino. Sure, it can measure your reaction time down to the millisecond, yet you have no way to read it. Today's part fixes that. Enter the OLED display. 4 wires, 128 by 64 pixels, and no dedicated graphics chip to help you. The Arduino draws every frame itself, which is why we'll spend a moment on what that actually costs in memory. Oh yeah, and it's worth noting the date too. August 23rd, aka today, is India's National Space Day, marking the Chandrayaan-3 landing. So let's honor that through this new component. 4 pins: ground, VDD, SCL, SDA. Only SDA and SCL actually carry data, and they don't work like a normal digital or analog pin. They use something called I2C. On the Nano specifically, those two map to fixed pins: A4 for SDA and A5 for SCL. So those two are spoken for the moment you add an I2C device. Now you may be asking, what's I2C? Fair question. Let's break it down before touching the display itself. I2C is a communication protocol, a set way for 2 chips to talk over just 2 wires. SDA carries the actual data, 1 bit at a time. SCL is the clock, a steady pulse that keeps both sides in sync. Every I2C device also has its own address, so multiple devices can share the same 2 wires, and the Nano just talks to whichever address it needs. Since there's no graphics chip doing this work separately, the Nano has to hold the entire screen in its own memory before sending it over. This display is completely monochrome, 1 bit per pixel, either on or off. And at 128 by 64 pixels, that works out to about 1 kilobyte, just to store 1 full frame. The Nano only has 2 kilobytes of memory total for reference. So, this one screen buffer is using roughly half of everything the chip has, even before your actual game logic runs. Zoomed in, it's simply a grid, each pixel either lit or not. The code decides which ones turn on to form text or shapes, and that decision is exactly what's sitting in that 1 kilobyte of memory we just talked about. Worth knowing too, this resolution, 128 by 64, comes in a few different physical sizes. 1.3 inch and 2.42 inch are both common, with same pixel count and same memory cost, just a bigger or smaller physical screen to look at. This right here is the simplest possible usage of an OLED, a singular line of text. This uses the Adafruit SSD1306 library to handle the pixel level work, so the code itself stays short. More on that in future episodes. And the OLED is done. 2 wires doing all the real work and a grid of pixels, turning that into something you can read. Next on the agenda is the joystick. No spoilers, so stay tuned for the next video. But until then, keep building at your own tempo.